Let's start to speak about distributed economy. We will see who firstly define this as a promising model for locally based resilient sustainability. Then we will see the main type and example of distributed economy to get an idea of what we are talking about, because maybe you are familiar with it, but I'm not that sure. So to be sure, the main characteristic, and then we will come to a definition. As well, we will see the main configuration. And here, at the end of the lecture, we will open up our mind to the wider system. This will be a little bit complex, but we will deal with it because indeed we have to take into consideration when thinking to a system level to different products and services. And something maybe they are not so visible at the first glance. And finally, yes, I will conclude with the definition of distributed economy, having understood all this. So the first question is, are there any other model than SPSS that are promising for sustainability? The answer is yes, they are distributed economy. And the first defining those were some colleagues from a university in Sweden, Johansson and other colleagues there. And they have been studying those to be indeed locally based and resilient sustainability. The way in which they define those was a selective share of production distributed to regions where activities are organized in the form of small-scale, flexible units that are synergetically connected with each other. And then continuing, okay, so this is coming from a paper. The concept called for a transformation in the industrial system towards distributed economy, departing from the socio-economical and environmental unsustainable dynamic associated with large-scale centralized production units that are favored by the neoclassical economic drivers, something that we have been facing during the last decades, always more and more centralization of production and distribution system, okay? But let's see some type and example of distributed economy. So what can be indeed distributed? The energy could be distributed, all right? Maybe we made an example even in the first lecture. So we can move from a centralized coal power plants to what? To a home-based solar power mini-grid, okay? So there is a big plant on one side, which is centralized, that gives energy to an whole region. On the other side, we have it's distributed because it's on the roof of my house, a solar panel, all right? That in this case, in the example, is then even connected to share the energy surplus with other nearby home. Even food that could be distributed. We can move from intensive farming and supermarket to urban gardening. So again, big scale production and distribution system to a smaller and more localized system of production. Even the water, so we speak about the distributed water management. So we move from centralized urban water supplies to decentralized access to clean water from underground, for example, or we can collect the water from the rain, or there are different ways, but this is not centralized, again, big plants, but distributed one. Even manufacturing could be distributed, so we move from, for example, a centralized furniture production company. It's a big company producing furniture and then distributing this all over the world to furniture that are 3D printed, so locally produced and maybe locally distributed, okay? But we can speak even about distributed software development, okay? So we have proprietary software, but we have even, as you know, Linux, which is an open source free software that is developed not by one big company in a centralized context and structure and department, but is co-developed by different persons that indeed integrate and update the same software, contributing to the use of the same software. Even the knowledge could be indeed distributed in terms of generation. We are not using anymore that much traditional encyclopedia, but indeed we are using Wikipedia, or now with artificial intelligence we are using even something else, but indeed Wikipedia is built by different persons, differently from artificial intelligence, by different person, expert, that gives contribution to, for example, in the chapter related to sustainable design for sustainability, I can give my contribution, and this will be over the Wikipedia structure that is, as you know, open access, but is built in a distributed way, okay? By different persons. Even design could be distributed, so what you are doing, so here we have an example of a design department of a multinational car manufacturer, but there are even platforms, open source platform, in which the technical drawing for cars are available, and you can, anyone can contribute, have access to the drawings, can contribute in improving the drawings, and so support the design of a vehicle in a distributed way. So different designers can contribute. With open access, we discussed this, what is, so there is not copyright over that, so everything is open, so they can contribute, everyone can contribute to the building of the design of a given product. So we have seen this different typology of distributed economy. And this is a classification that we did within the Lens network in the project that I mentioned you the first lecture, okay? So with different countries worldwide, from the Americas, Asia, Africa, and Europe, and so on. Okay, so what we can notice is that the first four are related to hardware and natural resources, so they are based on this, the energy generation, food production, water management, and manufacturing, and the other are more related to knowledge and information, okay? Software development, knowledge generation, and distributed design. Okay, so there is indeed a difference in relation to this, in relation to the outcome that we have. Let's go to see what are the main characteristics and definition of distributed economy. The first thing is the size or the scale of the production unit. Okay, for example, we have we saw first a coal power plant, which is a centralized system, which is a large, very large production unit. In a distributed, we move towards a small production unit. Another thing in relation to the size is the network. Even in the centralized system, we have great distributed network, and we can move to light sharing network. And why you may think that it could be a light network and on the other side a great distributed network. It's massive. When I have a big production system, whether I'm producing energy or I'm producing product, to distribute this, I need to have an infrastructure and a heavy system. And why is light when it's distributed? Because indeed many times it's localized. Okay, so I'm doing something to local people. Okay, I'm 3D printing something for a local people. In some other situation, it's not really so local. We may call it multi-local. For example, Wikipedia is indeed we are not in the same place. It could be that people or Linux is developed by people with a computer in different parts of the world. So it's multi-local, but indeed the network is light. So it's lighter, it's not heavy in terms of material, infrastructure, and so on. Okay? So it's a key important characteristic. And there is another key important issue which is related to who is controlling the system, okay? So the control structure. In a centralized system, think about who is producing energy. If we have a big power plants, who is deciding what is happening? The owner, the CEO of this, or if this is owned by a nation, by the nation and so on, okay? So the center of the system control all of the essential activity. It means if it is energy, they decide what is the cost of the energy, how to distribute it, where the energy has to pass, how to build the infrastructure, and so on, okay? And this is not only the case of the energy, the same is if I'm producing a product, if I'm developing a software, and so on. In a distributed system, who is controlling? If I have a solar panel on my roof, I'm the one that decides when to switch on and switch off and how to install it, how many to install, and so on. Of course, there are some limits because maybe not all the normatives are still favoring as they should solar panels, but they are increasing a lot, especially not that much in Western countries, but for example in China, there has been an increase in the production of energy related to renewable energies, And globally, it is so that renewable energy produce more energy than the energy that is produced by coal, by big plants using coal. But nevertheless, so we move from a hierarchical control of the structure to a peer-to-peer, where the nodes, it means me having the solar panel on the roof of my house, I can control this, or if I'm harvesting the water, collecting it from the rain, or if I'm doing something else, okay? So we move from hierarchical to peer-to-peer. To make a synthesis, a graphical synthesis of this shift to centralized, to distributed, and to see that we have even, when speaking about distributed, a slightly different type of distributed, which is called decentralized, we will see in a while. I will show you now a synthetic diagram, which is this. So if we move from distributed, from centralized to distributed, this could be decentralized, as I said, or distributed production and distribution system. You can see that this in the scheme. The control structure move from a hierarchical control, one to very many, one decide to very many, to a system decentralized, which I will explain a little bit better in a while, but I'm going to tell you even now. Decentralized, we don't have intermediaries, okay? So there are small production unit nearby the place where I'm living. For example, I'm buying the food from a local, small organic local farmer, okay? So I'm buying directly from this person, as other could be doing this. So there are no intermediaries into this, okay? If not, that would be someone that buys this from the farmer, then goes in another place, then goes to the supermarket, and then this is so we cut away all this. So when we speak about decentralized, is locally, is nearby, and there are no intermediaries. We have a direct relation with the one that is offering to us where there is energy, food, product, and so on. To a really distributed system where actually I'm producing myself the product. So I'm producing my vegetable or the energy and so on. And here is a distributed control or peer-to-peer when this is organized in a shared system, when we are sharing the energy or something else. The other characteristic that we saw, that I recap here in the graph, is the size or the scale of the production. We move from large, centralized, to small, to very small when we is distributed. And distribution system that move from great or massive to light or to very light when we are speaking about decentralized and distributed. Even a definition of a centralized system, okay? Even though this is not the core, but is important, is a large-scale production unit that control all essential activity, deliver their goods and services via great distribution network to many that are often faraway customers, whether they are individual, organization, companies, and so on. A decentralized system, here take attention because here now we are highlighting the difference between, again, decentralized and distributed. Here, don't be confused. We call distributed economy, and into distributed economy, we have two different types. One is called, again, distributed system, and the other one is decentralized, but they are still within the paradigm of distributed economy, okay? So when is a decentralized system? Is a system with small-scale production unit that deliver the goods and services via light distribution network directly to customer, no intermediaries, whether they are individual, company, NGO, or other type of organization, increasing the customer control on essential activities, okay? So they are not controlling directly what is produced, because if I'm buying something by a farmer, this is not, I'm not the one who is cultivating, but since I have a direct relation with the producer, as it happened in, we call them Solidarity Purchasing Group, gruppi di acquisto solidale in italiano, we can go by the producer, visit and see how they are producing the products and so on, okay? They could be standalone, or they could be connected with each other to share various forms of goods and services, for example, to share the surplus of energy. So the one on the right side, bottom right, is standalone, let's say. The other are two that are connected. For example, I have a surplus of energy in my home, and I can share it, and I can give it to my neighbor, because there is a network, and maybe he's or she is in need of this energy, and vice versa, okay? So we may have the two situations. And here we see a distributed system, so really distributed, so the difference between the centralized. We have very small scale production unit of goods and services located by the end user, not nearby, by the end user. So it's in my roof, it's in my garden when I'm cultivating, okay? Or when I'm harvesting the water, or when I'm 3D printing is in my garage. It's by the end user that become indeed the producer. Usually it is common to use the word prosumer to take together producer and consumer, that have the control over all the essential activities, whether again they are individual or entrepreneur, other type of organization, and so on. Even these could be we may have a situation which are standalone, like again on the bottom left, on the bottom right, so there are no connection between the different distributed system, or there could be a system in which there are connections. So maybe I have a mini grid in my neighborhood of energy production with solar panel or other renewable energy sources, and this could be connected with another nearby neighborhood that has a network that is sharing the energy. So I can share the energy with a nearby other mini grid. And here we go to see another interesting issue that we have to be aware, but because there could be different type of configuration, okay, of this distributed and decentralized system. We said already standalone or connected with others. Indeed, here we have production unit could be centralized. It's not really our core interest, but we put it anyhow there. Decentralized, distributed, and then hybrid production unit. And then we see if we have a network if they are networking, if they are sharing goods and services or resources and so on. Okay? So let's start. Okay, centralize is it's usually a network, a big network. I don't have to say much about this. It could be, as we said before, big coal power plants that produce energy and distribute the energy. Indeed, this could be network of network in the sense that, for example, even though it's a centralized system, we are buying energy from France, which is produced by nuclear central plants and so on. Okay? But let's go to what interests us the most. So when it's decentralized, so nearby, and is standalone, let's make some example. So I go closer to the question that was raised before. And why is it interesting to understand all this difference? Because indeed, when you will be designing, it's good to know that there are different options on how to design the system. And this option could be more relevant and effective for a given context than another. So in relation to the context for which you are designing, you select the best configuration. So if this is decentralized and standalone, I put here an example. So it's a local hydropower energy charging station where people go to charge their phone. So is decentralized, it means it's not by the end user, is nearby, is in the community, okay? But the provider of the energy has not built a network for distributing the energy, okay? Are the people walking to the place and charging the phone. So it's, we call it standalone. I make another example for distributed food. There is an organic food producer that sell directly to local, but where is organized the purchase on field. So actually the producer has not organized a system for the distribution of the food as it may happen. Okay? I don't go on, but in the slide you may find an example for each of the typology of decentralized system that I mentioned. Let's see when is decentralized but network structure, so different from standalone. An example is what I put here, a small wind farm which provide energy to villages with a local mini-grid. So there is a wind farm so that is able to, for the villager to produce the energy that is needed. So it's not so small as the one that I may have to produce the energy on my home. It should be a little bit bigger because it should provide energy to the villager. But why we call it network? Because who is providing the energy is has even installed a local mini grid. So the energy there are the cable that take the energy to all the houses of the village. Okay, so there is the distribution network, in this case of energy. And I have another example again related to food, what I put here, a local baker delivering organic bread to the neighborhood, but he is organizing this, taking the bread with a solar vehicle that he has purchased or maybe has taken as an SPSS. Okay, so is again decentralized, nearby, so it's not buy. I'm not producing my bread. I'm buying the bread directly, but the baker is organizing the distribution of bread. And here, if you are curious, you can look at that other example. As we have seen before for the centralized system, indeed we may have a network of networks. So I have a network of decentralized energy production that is distributing this energy to local villager, but this village is connected with another, not so far maybe, village, and being able to share the surplus of the overall community energy with the nearby network. Another situation is the situation in which a decentralized system is connected with a centralized system. So we may have a connection with the main grid. It could be that in some situation I can sell the energy to, if I have a surplus of energy produced by my solar panel or by a community that is producing, to a big supplier of energy, and vice versa. If I need some energy because my system doesn't produce enough for my needs in that moment, I can take the energy from the centralized system. Let's go on and let's look at the distributed system when it's standalone. And here again, I put an example. Distributed is when it's by the end user. Again, I'm saying, so here I put a home-based solar panel for a single countryside household for own energy production and use. So there is a person in countryside is producing the energy, and maybe to build it's so far away from many others, to build a connection that are not nearby producer of energy could be too costly or unnecessary. Okay, so it's producing is in that case is standalone. I have another example like home gardening for private use. I'm producing my tomatoes, my vegetables, and I'm eating by myself. So this is standalone. Again, here you may read for curiosity other example. But a distributed system could be a network structure. That means that there is a sharing of products or resources and so on. So again, in relation to the energy, there is a set of local solar panels for home use connected with the mini grid that is sharing the energy surplus. This could be the example that you mentioned before, but it could be that they decide to have even a decentralized system that is sharing the system. It depends situation by situation, okay? And even about the type of energy that is more renewable energy that is more available at that stage. I put an example even in relation to food. So in the neighborhood, there is a gardening club that is sharing the surplus of energy. For example, I'm producing tomato, I have a surplus of energy, and with an app, I'm communicating to the other the other person living nearby me, being part of this club, if there is anyone that wants some tomatoes because I have too much, and so on, and vice versa. Okay, so there could be even in relation to food as well as for the other, and you can look at the example. Then, as we have seen for the decentralized, we may have a network of distributed. Okay, so we have a network, and this network could be connected with another network, and so on. And again, this network could be connected with the centralized system. Okay, who is producing energy or producing food or whatever is producing. Finally, we have hybrid system. So we may have something that is decentralized, but partly distributed, because I'm anyhow collecting some energy from my roof, or I'm doing something like this. And this could be connected indeed in network, and it could be network of network, but indeed is not just decentralized or distributed. It could be even a mix of the two, or it could be even that is connected to a centralized system. So at the end, indeed, that this is to give an overall picture, the range of configuration that we may have in mind when we are designing a system, either is for food production, or is for energy production, or is for software production, or whatever it is. And here I have one last issue, which indeed makes the discussion a little bit, if you think that so far it was complex, now it's coming really a little bit more complex. But to be able to think up to a system level, we have to be aware about something. If not, we make. So we have to be aware, all right? So the point is to make an analysis of the distributed economy profile from a wide system perspective. So indeed, what we have to have is a focus on all of the components related to a satisfaction unit. Satisfaction unit could be, for example, eating in Bovisa campus will be the design exercise that you will be doing. But could be whatever, having clean clothes or something else. So the components. The first component is the distributed economy production unit. So we have to identify in relation to the satisfaction unit which are the type of distributed economy production unit that are involved. If it's for food, I need the food. So the wide system, I need to look at the food production system and how and if this is distributed. But then maybe I need for the food, to produce the food, I need even some water. So I need a water collection system and so on. So we have to identify the different distributed production units that are related to the satisfaction unit we are working on, okay? And it could be just one, or many times it could be a combination of more than one. But we have to think even to the distributed economy produced unit. So what we are producing, the outcome, is if it's a distributed generation, energy generation, what is the outcome? Is energy. Food is food. So here is coming clear. It's software, it's water, it's this. But indeed, even this has to be taken into consideration if these are part of the satisfaction unit. The story is not that simple because indeed we have to consider even other related products or resources that could be needed as input when we are producing or using the outcome of a product. If I have in my balcony, I'm cultivating my tomatoes, okay? I need to have some water to irrigate the tomatoes. I need the seeds to make the tomatoes to grow and so on. So these we have to consider not only the distributed production unit and what is produced, but even the resources or the semi-finished product that are needed to produce what I need. If I have a 3D printer, I need some PETG to do the 3D printing here at the lab or PLA or whatever you're using, and so on. But the system, so looking at the system level, it means to look at all those issues. The point is, and here it becomes even more difficult, that all of these components need to be considered in relation to the life cycle stages, okay? So here, try to take attention. You remember which are the life cycle stages? Pre-production is when we produce the material, production, we produce the product, distribution, use, and disposal. And the point is that we have to consider whether in relation to each of the components, in one of the phases, something could be distributed, decentralized, or centralized, okay? So for a given, could be for, let's say, a 3D printer, we are analyzing a 3D printer, okay? It could be that for the pre-production, it means the material, the 3D printer is taking the material from multinational of material production, so it's centralized, so pre-production is centralized. Then the production could be made in my garage, so it's distributed and so on. So indeed, along the life cycle, the story may change, and so what we are going to do is indeed to make a profile. You see that red line highlighting this. But since this is a bit complex, I need to make some example. If not, you don't get up to anything. So I'm here, distributed production unit, this produced unit, and distributed economy satisfaction unit, related product and resources. So something that is needed within the satisfaction unit to do the things. So for example, distributed production unit, I may have, when is a local energy generator, for food, small land, farming, breeding, equipment, etc. For water management equipment, for manufacturing, 3D printing, and etc. Okay? The distributed produced unit is very easy because we produce energy, food, water, product, software, knowledge, and project. So this is easy. Here it becomes a little bit more complex and fluid, because if I have a solar panel, I need the sun. If I have a diesel generator, I need the diesel as a resource to fill this. But this has to be considered. Said this, I make an example with the distributed energy generation. Okay, try to follow me. So I have a solar kiosk panel. Okay, so a solar kiosk, it means is distributed or decentralized. Solar kiosk works for different people in a village, let's say. It's the work for different people in a village, decentralized, okay? So we have a solar kiosk panel, but if we look at the solar kiosk panel, the same solar kiosk panel, when we look at the pre-production, it means the material. All the material may come from a multinational of material producer. The production could be, so it's centralized, okay? So the pre-production is centralized. If you look at the production, even the production is centralized, because it is a multinational manufacturer that is doing this solar kiosk. Indeed, if it's centralized the production, even the distribution is centralized, because it has to be distributed. The use, if it's a solar kiosk, you said it before, it's decentralized, and the distribution, the disposal, we suppose that it goes to a local landfill, so this is a decentralized system. That means that the solar panel would draw a graph that would look like this. So you see that saying distributed, decentralized, or centralized is not that easy. It's not to say, okay, solar panel is distributed. No, it depends. The material, where are they coming from? Okay, I'm producing my tomatoes. Where the seeds are coming from? Where the fertilizer are coming from, and so on. The distributed produced unit is energy, and the pre-production is the sunlight, so the pre-production is indeed distributed, because the sun arrives there where it is. The production is decentralized because it's a solar kiosk. The distribution is decentralized because we have, in this case, a mini grid. The solar kiosk has a mini grid, and the use is distributed because indeed we are using the energy by us. In terms of disposal, there is nothing, because when the energy is used, it's used. If we have to think in relation to the satisfaction unit, and into the satisfaction unit there is a need of a smartphone, even the smartphone has to be considered. And again, we have to consider pre-production, production, distribution, use, and disposal. So we may have a graph in which the material are produced by a big manufacturer, so it's centralized. That means even the production and the distribution. The use is distributed because it's made in local. We are using the mobile phone, so by necessary. This is so, and and the disposal goes to local landfill. So we may say that this is, well, it depends how big is the landfill space, but we can say that is decentralized. Okay, so you get a little bit the complexity of the system. It's not that easy, but it's important to understand this, because if we forget to understand this, we really think that, you know, doing something that we think is a happy life with very sustainable behavior is indeed not at all, or we think it's distributed, but this is not, or is partly distributed, but not all. I have another example, but I leave it for you in the slide. I'm not presenting here in relation to this distributed manufacturing, where there is a 3D printer, the product that is printed, and what is used by the 3D printer, but indeed it's needed some energy and some material and so on. And so we can draft in relation to how the system has been designed, our system. What I show here is not fixed. The point is that we may make an analysis, a map of the system, or how is it right now, but then we can design it in the best way possible to be environmentally, socially sustainable, and even economically beneficial, but we will see this later on. So the point is to indeed look at this, to come up with related maps, okay? We are not going in the design exercise to build this kind of maps, but it's good to have in mind that there are different actors, there are different life cycle stages, and to think up to a system level brings inside the complexity, but without thinking about this complexity, we fail totally. To conclude, and this is the last slide, and then you have your deserved break, because it was a long part, we have a definition of distributed economy, and we can read it together maybe. Distributed economy are characterized by small-scale production unit, shifting the control of essential activity towards or by the end user. Towards is decentralized, by the end user is distributed, whether they are individual, entrepreneurs, or other type of organization. There are no intermediaries, or the producer are the same end user, okay? This is the difference between distributed and decentralized. The production unit could be standalone, we have seen, or network structure with other distributed economy unit that share the various form of products and finished products, resources, service. In this case, we call them distributed economy network, or as an acronym, DEN, which actually then can be connected with other network. And here it comes, if properly designed, they are promising to promote locally based resilient sustainability. In other terms, sustainable development energy. But this is something that we are going to see in the next part of the lecture.